Hello everyone, welcome to Excel Maths. So we have question number 3 over here from mock set 4 mechanics. So let's get started. Over here we can see we have string, we have pulley, we have two masses P and Q. So two particles attached. Going through the setup, I just tried drawing something, creating something. So I'll be sharing the screen to you. So if I just quickly share my screen, share that particular part. If you see, this is what the setup in the question given to us. What we're going to be doing, as the object P is sliding down, that means we are going to be having Q moving up. Correct? That is clear. Now what we need to do, because they are moving, there would be some, forces. We have to resolve all the forces and solve the question. Okay, so what we're going to be doing, what I personally prefer for the object which is on the plane, this slope, I just try to draw a plus over there. How do I draw? First I draw a line which is parallel to the slope and then the perpendicular to that one. So this is my plus, and right from this what do we call it, point of intersection of these two lines, I draw W, weight, which is exactly perpendicular to the bottom plane, like this. So this is what all the forces for P are done. So only a plus, and then from point of intersection you have to draw a line down, which is the weight. Weight should always be perpendicular to the surface, like the bottom surface where the slope is inclined to. You have not to think of weight, and this weight is not at all connected to perpendicular to the slope. Okay, now when we talk about Q, so for Q we have two forces, one going upwards and the other one going downwards. Now let's see what all these forces are. So the first is, we have the weight, that is kmg. Weight is nothing but mass times gravity. So km is the mass of P and g, kmg. Now the angle between the weight and resolved force is alpha. So we're going to be getting km cos alpha there and km sin alpha here. Tension, the string is tight, so the tension is going to be there. Now when we talk about Q, so down there we're going to be having mg, that is the weight of Q with mass m, and up side we are going to be having tension on string. The one which I missed labeling is the reaction force, right? So we're going to be taking the screenshot of this, and let's go back to the work area where we can solve the question. Okay, so I just have taken the screenshot here. Wait, here would be moving it there, and we'll try solving the question. So we can see all the forces are already resolved. So what first question is asking us, A part is asking us to find out, we have given some informations are given to us. Acceleration is 1/5 of g, so we are going to be writing it 1/5 of g, and tan alpha is given to us. Okay, so if tan alpha is given to us, you can see that we have sin alpha and cos alpha in picture. That means we obviously need to know the values of sin alpha and cos alpha. Sin alpha, let's quickly draw a triangle. It's alpha with tan alpha, TOA, opposite is 4, adjacent is 3, so that one would be 5. Sin alpha is 4/5 and cos alpha is 3/5. Correct? So I feel like we've got all the values. Now let's do A part, which is asking us, okay, over here the plane is being modeled as being smooth. If it is smooth, that means there is no friction. When the word smooth comes, what is it actually telling us? It is giving us the hint that there is no friction. You would be clear with that thing. So we have not to think about friction like F max equals mu r. No, we need not to think about that thing right now. So initially is model, that means we would be definitely be having the second model over here, which would be rough. So right now we have no friction there. For A, we need to write the equation. for P. So for P, let's just focus on P only. So the P thing is like these forces. So what we have acceleration downwards, so downward force is stronger, right? This side force is stronger than the up, downwards the slope is stronger than upwards the slope. So we have kmg sine alpha here and t over there, so obviously kmg sine alpha is stronger than t. Okay, we are going to be using F equals ma. Force is the resultant force, which is going to be represented as kmg sine alpha minus t, that is equal to, mass is km and acceleration is 1/5 of g. Okay, this is what is going to be giving us 2 marks. Very well done. Now for B part, let's do B part. For B part, it is asking us find the value of k. To find the value of k, we can't really find without using q. So let's write down the equation for q using F equals ma again. So it would be, this time, can you tell me whether t or mg is stronger? We just check the direction of acceleration. Right now, acceleration is going upwards, that means supporting t. So t is going to be stronger. This is the greater symbol. T is greater than mg. T is stronger than mg. Hope it makes sense. Now, we're going to be writing resultant force is T minus mg is equal to m, and acceleration is 1/5 of g. We have these two equations, equation 1 and equation 2, like this is I and that equation is I. What can we do? We can just add them both, because minus t and plus t, it would be 0. So what we are going to be doing, adding I and I. If we add them both, it would be looking like kmg sine alpha minus t equals, can I say 1/5 of kmg. Down there we'll be having t minus mg is equal to 1/5 of mg. If we solve them both, where we have to add them, just add them. So it would be cancelled, will give us 0, and here we will be left with kmg sine alpha minus mg, that equals 1/5 of kmg plus 1/5 of mg. What we're going to be doing, moving k's to the left side and mg's to the right side. So can we say that kmg, let's substitute the value of sine alpha, was 4/5, I guess. Yeah. Sine alpha was 4/5 minus 1/5 of kmg, which is equal to mg plus 1/5 of mg. Okay, so it would be, if you take kmg common, 4/5 take away 1/5, it would be 3/5 of kmg, that gives us 1/5 and 1, so it would be 6/5 of mg. Okay, so as you can see, 5 to 5 would be cancelled, and kmg, mg would be cancelled again, so you have the value of k is 2. K is 2 over here. Correct? So yeah, this is what gives us 4 marks. Very well done. Now for the second one. In a second model, the plane is modeled as being rough. That was quite understood, because the first model is giving us a smooth plane. If the plane is rough, that means we have friction over here. So can we say F max equals mu r? So what we need to do, the need is basically we should know r, and I feel like every time whenever the friction thing comes, First question actually helps us to find out the other one. So R, if they are not giving us this, we still need to find out R. So better we are getting the question and getting, mark for that. So yeah, so over here, the coefficient of friction between P and the plane is mu. That's fine. P remains at rest, but P remains at rest, but is on the point of slipping down the plane, but remains at rest. So using this model, we have to find out. I would be telling you what mistakes can you do, or if you would have, attempted it before, what mistakes are possible here. So I'm writing. Probably once let me do this, then I'll be showing you what mistakes can we do there. So for C part, I'm doing C part here. So for the C part, what we need to do, we need to find out the magnitude of the normal reaction exerted by the plane on P. So shall I take this structure down there? If I copy it, okay, move it down, right. So we have it here. Now we have to talk about resultant normal reaction. So normal reaction R is acting upwards, which is opposite to kmg cos alpha. So R equals kmg cos alpha. We have to add one more thing which is added over here, that is the friction. So okay, it is at the point of slipping. If P slips, so it will slip down. That means the friction would be acting upwards. F max, the direction of F max would be upwards. This would be clear. This is F max. Okay. Now we were talking about a reaction. So kmg cos alpha was 3/5. So can we say 3/5 of kmg? Now from previous part, we found out the value of K to be 2. So finally, can we say that 3/5 times 2 mg, that is going to be giving us 6/5 of mg. Correct? So the reaction force is 6/5 of mg, and here you lost your mark. Why? You can't really take the value of K and substitute over here because setup is not really the previous one now. Initially, we were having the object was sliding down. This time the object is not moving at all. The object is at rest. So you can't take those conditions to be applied over here. Right? So what the real correct answer will be, don't substitute it, is the final answer. We have got our final answer here. Right? Okay, so C part gives us R equals 3/5 of mg. So I'll be removing what the mistake part was, and it was important to show you, that's why I've done that. So yeah, C part is done, and now what we need to find in terms of K the value of mu. Okay, the common sense says that if it is saying in terms of K the value of mu, that means K we can't substitute 2 there, right? So see, for example, if you made a mistake, you would be rectifying that, and in first one also in terms of K, M and G, so probably you are not going to be substituting the value of K, no? So I think I'm the silliest one who has substituted the value. Never mind. So let's go to the D part. For the D part, we have to find out the value of mu. So we know that F max is equal to mu R. R is already done. So mu and R is 3/5 of kmg. Correct? So this is what F max is. And if we try writing the equation like for P over there, so just for the particle P, it would be F max and T, they both are, we are using the same thing. Let me write first F equals MA. So F max and T, they both are acting in the same direction. So they are going to be, stronger. Minus, let me add in the bracket, minus KGM, really? KMG, F max and T are acting in the same direction, but because the object is not moving, so that one is stronger, and KMG sine alpha is weaker this time. These acceleration are no more making any sense, so we can just, it's nothing there. Just think like that. So there is no acceleration. This is the second case where acceleration is completely removed. Okay, so KMG sine alpha, which is equal to KMA. Okay, now you tell me one thing. Can we substitute the value of A, which was 1/5 of G? Can we substitute it here? Just think. No, we can't. Because it was acceleration when the object was moving, sliding down. So we don't know what the acceleration would be because the object is not moving. Okay. And when the object is not moving, that means it's 0. Let me take some of my words back. Instead of saying we don't know, we basically know that acceleration is 0 because the object is at rest. When the object is at rest, that means acceleration is 0. So it's going to be, it will turn up to 0. Okay. So can we say that F max plus T is equal to KMG sine alpha? Okay. Now F max is mu r, so let's substitute the value of mu r there. So mu times 3/5 of KMG plus T equals KMG. Sine alpha was 4/5. I'm just substituting. Everything is fine. Let me fix it first. 3/5 of mu mg plus T equals 4/5 of kmg. Actually, everything is fine. The only thing is this T. How will we, solve for T? We just need to get rid of T, isn't it? We have to, it's not asking us to find out the value in terms of T. So probably we need to use this setup, the Q thing. So because the object is not moving, so your T is going to be equal to mg, right? So we are going to be substituting mg here from what we have discussed. So it would be like 3/5 of mu mg plus mg is equal to 4/5 of kmg. If we divide whole equation by mg, dividing, so it would be, mg thing would be removed, so we will be having 3/5 of mu plus 1 equals 4/5 of k. When we get same, let me not complicate that. Okay, 3/5 of mu is going to be equal to 4/5 of k minus 1. Okay, so if you simplify that, it would be 4k minus 5 all over 5, 3/5 of mu. So here, if we divide, or maybe just times it by 5, both the equations, you're going to be getting 3 mu, that is equal to 4k minus 5, divide by 3, you're going to be getting next step, that is mu, which is equal to 4k minus 5 over 3. And this is what the final answer we've got. Let me check here. So first equation was kmg sine alpha minus t equals km 1/5 of g. That is there. Here we have. Then the value of k was 2. Then the third one, what we need to find out there? Okay, r was 3/5 of k mg, and d part is 4k minus 5 over 3. Yeah, that makes sense. Very well done. Bye bye. 3 seconds for 20 minutes. Okay, done.